So work with Z not, I don't know.
Like the invertible set, the invertible element set. I mean, the elements set it's S asterisk. So to be able to be invertible, P power L over Z should belong to S. So we select only all pk that belongs to Z. So
No, wait. That's not a correct notation. What does element of Z mean?
okay, I will say all the okay.
I have a question. What does this mean? This is a number, and this is a number. How can a number
This is
invertate
a
in a
Z
number?
integer. This is a set of integers.
Aha, okay. So should it be like this, right?
Okay. Integers. So
I have a question.
we will write the last
For the
notation
first
and
one,
I could
is it
explain
okay to just
everything.
show that it doesn't have
Yeah, that would suffice if you want.
the inverse is
Yes.
okay.
Positive or negative en such that n belongs to Z equal to P power L divided by P power K such that K belongs to n0. So that is my final solution. This is what I have written, that the invertible element set S asterisk. This is the set asterisk. S for asterisk means that this is a set which contains only the invertible elements. Okay. So what was our problem in the previous notation? Why we proved that it's not a group? Because we found that there exist some elements that has not some inverse elements. So here in S asterisk we exclude all these elements which cannot satisfy which has not an inverse element. Okay. So what are the elements exist in this S asterisk? In order to be able to invert all the elements, we should have this P or L divided by Z belongs to S, right? So we must satisfy this condition that our element should be like integer divided by a prime to the power of L. So that's what we want to choose here. So our problem was in here in this denominator. So we want to get elements which like p to the power of k, and this p to the power of k will be our denominator here. That's what I written here. This p to the power k should belongs to these integers. Why this should happen? Because if this pk belongs to these integers, this means that the denominator will be also belongs to and satisfying the condition of the set. Clear?
I think what you mean here is each power of k and k is an integer. Could that be? P to the -2 would also be something.
But I wanted to say that p to the power of k. I think this is a.
Should it be?
No, actually,
K should be
power
that
of
number.
-2. That should be in the set as 5.
Or Z plus.
But I wanted to say, I think it's like.
You wanted to say like the whole that Z should be a prime to any power. That's where it will satisfy the group condition.
No, K should be just a positive integer or 0.
K does not have to be positive.
Yeah, because this is how we subtract the generator.
Because it can flip.
Yes.
But I think I understand what he's saying.
I
Like
demonstrate that I want this denominator to be belongs to the
prime.
So that's why I didn't restrict the k only. This pk also should be belong to the.
It doesn't make sense.
Yes, but what I meant is that you don't want pk to be in the integers. You wanted the number k to be an integer, right?
This one.
No, I wanted p of k to belong to the integer.
You know, there's 4 sheets now.
Because that's what
Okay, but when you have elements, for example, 5 to the power of -2 that are it's still integer.
But like if it's not integer, then like this is I
You
guess
have
it's,
the z is an integer.
Z is integer and L belongs to N of okay. So yes, back to our demonstration. So we want to satisfy that the denominator is pk and to be part of our set, which is like definition of here written above, that S should be have elements that Z over divided by prime number to the power of a of L. So now if we have only these elements considered, we can define our S asterisk or our set as following. It is any positive or negative integer where we have prime to the power of certain digit, and this digit belongs to this set. And this is the notation of the system.
And using that as well to
Yes. Like I write this digit as an integer.
But that should not be an integer. That should be just a normal set, right? Otherwise, it wouldn't make sense in a fraction.
Sorry for this confusion, but like, and our final pieces are, or my final representation for the solution, it should be a prime number to the power of L divided by a prime number to the power of k, and this should like they are not the same value belongs to S, where this L and k belongs to N0, and this should be satisfying the S.
Yes.
Right. Can I say something like, so with only plus minus t, I think it's only plus is sufficient because we cannot generate a negative, or we can generate, we can use